Yes, recording started.
Okay. So the contents of the translation look-aside buffer, as we were discussing before, must be coherent with the contents of the page tables in the memory, right? Similar to how we were discussing how the contents of the cache must be coherent with the contents in the main memory. Similarly, like the contents in the TLB must also be coherent with uh, the contents of the page tables in the main memory, right? So that's an analogy over there. And then we looked at the translation procedure over here, right? We looked at how the address is translated. And yeah, a page fault is essentially when there's an access to a page that is not there in the main memory either, right? So if there's like access to a page which is not there in the TLB, that's just a miss, which we can just, that's a page miss. But if there is an access to a page which is not even present in the main memory, that is what we call a page fault, right? And we also have page replacement will be required in the TLB in the same way that we needed replacement in like the cache, right? Because the cache is smaller and we needed more blocks. So in a similar way, the TLB is smaller than the main memory, and we will therefore like require the TLB is smaller than the page table, and it will therefore require like page replacement algorithms as well. So write through is also like generally not suitable for the virtual memory. Since you don't want to like directly since if you would want if you use write through, the latency will become higher as writing to the secondary storage will become like even more expensive than before, as we were doing write throughs in the cache. We were just writing through and writing through the main memory directly parallelly with the cache. But over here, since we are going to be directly writing to the secondary storage, the write-throughs will be even more expensive. So it's not suitable. And of course, we will be using the same locality of reference principles to like design our algorithms in the virtual memory as well. So yeah, so for memory management, we require like some basic some basic things that we require are that we need multi-programming. Like if multi-programming is not allowed, it will become difficult for us to manage our memory. And yeah, we need like a separation between system space and user space. Like the kernel can only access a specific space, and the user cannot access the system space. So there needs to be a boundary between that, and there needs to be proper protection. Like there needs to be different states, like supervisor or user states, and there needs to be privileged instructions to keep like your system protected, right? And you need to also since the program is being broken down into different pages, you need like the communication or you need shared pages, right? You need communication, you may need communication of the data between pages sometimes, like data or instruction to like have an efficient memory management, right? So that is it about memory management requirements. And I think secondary storage is something that we will not go much into detail about, but as we were saying before, it includes things like magnetic storage and this and it has magnetic disks that we will not go further into, but we can look into further. But you can look into on your own. So yeah, I think that is it for this chapter. And yeah, thank you guys.